Okay, this video is part 2 of trying to repair the Mr. Astronaut, which was a very tall plastic robot made in 1969 in Hong Kong. And if you watch part 1, which I'll put a link to down below, you'll see that the leg linkage parts, those are the load-bearing and mechanical functioning parts, were broken. And well, in this case, what you're looking at is the front one, which actually does the walking, and here's where this one was snapped and broken. And I thought I'd go through and show you how to CAD and make up some of these parts for 3D printing in mind. This particular one we'll just talk about. I think what I'll do is I'll start from square one and show you actually how you make a part. For example, this is the rear leg linkage part from the robot, and there is a left and a right one. They're symmetrically different because the nub sticks out one side there, and then there's a difference in length there. But this is one I glued back together because it had broken at their joint, which they actually were holding this part and this part together with wire pins that were hot melt in. You know, in other words, they heat up the metal and then push the two parts together. Never really seen that done before, but my best guess is that the injection molding machine that was used for this robot had a maximum size of what parts could be made on it, or they wanted to design this toy to be able to be used with smaller injection molding machines, because that might give them more different shops that could make it at a lower price. It was Hong Kong after all. And in this particular case, this piece, if I move it, maybe if you're not seeing the three-dimensional part of it here, would be sitting flat like this when it's printed on my printer. And the reason for that is printers go in layers, and I want my layers to build this way. If you did anything vertically, then it would tend to snap on the layers, because this way you get your maximum strength. And once the part is printed, this little piece here would get glued on there to complete that part of it. And these two spacers are the same size, and they can either be glued or left unglued, but they go down at this end, which would be those two things there. In other words, they don't have to be glued because there's an axle that runs through there and they're basically spacers. I'll glue mine though, because it will add some rigidity to the part. The crank that's in the gearbox of the toy runs in this slot, and that's what actually makes the leg, you know, walk forward and backward. And this hole up here is going to be for driving a steel pin through, which pivots to move the arms. So when the legs walk, the arms move. So the program I'm using here is called Design Spark Mechanical, and the main reason I'm using this over all of the flavors of the week that everyone's using these days is Design Spark Mechanical was a free CAD program clear back in 2013, so 20 years ago. There weren't very many options for free CAD that could do all of these sorts of things 20 years ago. Trust me, back in the 1990s when I was using CAD for my PC board layup and case design for a company called AEI Music Incorporated, it was very, very expensive for those CAD programs back then. And you couldn't even take them home. The computer had to have a device we call a doggle or boondoggle plugged into it. I mean, there weren't USB ports even back then, so it was either going to be a serial connection or a parallel connection, and unless you had that device, the program wouldn't run. So even if you had the program, you couldn't spirit it off and use on your home computer or anything else. It's too expensive. They had to protect that. So anyway, way back in 2013 when this came up and being free, and it had basically every function, and they've kept developing it and they've kept it free, and you can find all kinds of tutorials on YouTube for Design Spark Mechanical, or DS Mechanical as they like to call it. You'll find that it is one of the better ones. It may not be popular, because there's been so many new ones since then, and then there's ones where you maybe don't want to learn CAD, but you need to make a part where they just give you native shapes and sizes, and you just put things together and rescale them and poke holes in them, and like Tinkercad, for example. So there's ones out there for people that don't want to learn CAD, but do want to make something. All right, so let's close this out. This is the normal starting page you would see when you would open their program. And I'm going to go up to File, I've gone to New, I'm going to hit Design, and it gives you this plane. I don't like working at an angle. I like seeing a plan view when I'm doing my stuff. And what we're going to try to manufacture is this piece. And I want to design it so that it will lay flat on my printer bed and print in this orientation, and I'd like it to print all as one part. So one of the first things you're going to need is some set of micrometer or a good ruler or something, and these are not expensive to buy, but measure between the two axle points in this particular one. And I'm not going to try to keep all this on camera where you can actually see and everything. You're just going to have to take my word for it. But basically it's 124 millimeters. And I'm going to go with a 3 millimeter shaft hole. So the first thing I'm going to go up to do is select this circle making thing on this drawing. I might as well just start right there, poke that in, and let's make a 3 millimeter circle there. And we know that the other circle is going to need to be exactly 124 millimeters away. Select that. I hit line to do that. Then I'm going to go back to the circle, come back here. Oops, it's not the size I want 3 millimeter. There we go. So now I have my two 3 millimeter holes, and I know that they're exactly the right distance away. I'm going to clear this center line out. I don't need it, and it'll leave a little bit in here. We need to clear that out. Using the scroll wheel on my mouse to pull in and pull out. There we go. Centering things up can be challenging. There we go. Try to keep this where we can see it. Now, because I want this to print flat, the bulk size that I'm going to put around here, because right now we just have a hole defined, we don't actually have a physical thing. I'm going to take this polygon maker and go to the center of this hole, for example, pull that, and I think it's not really super critical what size I go with. I'm going to go with 7 millimeter. And let's do that to the one over here as well. And let's say 7, like that. Then I'm going to join those two together, start forming the piece like that. And as far as the thickness, you know, how thick do I want to make this for strength reasons? Well, I'm going to add more strength to this than it may need, because why not? I'm going to go, well, let's just go right to the center line. Let's make it simple. Just go to here. Let's drag that all the way over to that one. So now we've got a nice thick line there, and I think I'll go back later and we'll even add more to that. But let's start with what we have going now. Now that we have this basic drawing here, I'm going to go up to Select and Mode, and now we can select things and actually start extruding and adding some depth to this project. And it doesn't stick out on this side, it's going to stick out on that side. This part actually has to be made as a left and a right hand part, so whichever one I make here, I'll use the mirror function to just change what I already designed to make the opposite one. So it doesn't really matter which way I extrude this one now, because I can go back and redo it later. So let's see, width of the main body of this thing, got about 9.5 millimeters. So let's hit this part. I'm going to rotate this a little so we can see what's going on. Then I go to the pull, and then I just start dragging, holding the mouse down and dragging, and I can type in 9.5. Is that what I said? I think it was. Better check. Yep, 9.5. Okay, so now we've got the width that we wanted. And I know that I want got an error on my micrometer. I was trying to measure and it says error, which I've never seen before in all the years I've owned it. 3 millimeters. So basically, on this part here, I want this hex part that I've got there to come out at least 3 millimeters further than this side. So we already know we had 9.5. So if I select that, and I go 9.5 plus 3 is going to be 12.5. So I selected it, now I hit pull. I'm going to pull this, and then I'm just going to type in 12.5. Boom, like that. So we've got that one. Now what about the one on the other end? One on the other end has got to stick out roughly, looks like about let's say 8.2 further. So we had 9.5. God, I need my calculator out here. 9.5, 8.2. That's going to be a 0.7. That's going to be, so 17.7 roughly. I'm going to select that. Come on, hit the pull and say 17.7. There we go. And I'm going to hit this pan button to give me a, well, I'll just come down and use this box. You can change the orientation of what you're looking at. I wanted to get a straight on view because back when we did the whole thing, I left a fill area in there which we're not going to be using. So I want to right click, hit delete, so we actually have a hole there. Delete. So now really the only part that we have left to address on this is this hex on this side needs to be extended out yet. So I'm going to take that, turn it so we can see it, and I'm going to highlighted it. I'm going to go up and hit my hex tool again, or polygon as they called it. Redrew that on there. Going to select, going back to mode. Now I can select just that area. And now we should be able to pull that. And I'm going back to measure my part to see how much we want to pull it. Looks like about 9.5 millimeters. So I hit the pull, take that, pull this, 9.5. Boom. It looks like it just put in 9. I said 9.5. There we go. I'm going to use this direction box here to give me the side view again because I need to clear that hole. And where's my delete? There's the delete. Alright. Hole's clear there, hole's clear there. And there is the part that should lay flat on the printer and should work. So you would then, at this point, if you were going to save it, I already have the file saved, but you would go up and hit a save as. Box opens up, you'd give it the name, you would save it. And in my case, like I say, I already have it. Or you can go up here to the export options and you can go clear down and just save it also as an STL file. The first file it was saving in was a DS file, Design Spark Mechanical. That you always want to save in that way too, because then you can come back and modify it. If you didn't do something right, you can go back in and modify it. If you save it only as an STL, you're kind of screwed. So you need to save the same file both ways. You just hit the STL, it would pop it up. If you'd already given it a name and saved it, it would already have filled all that in for you, and then it would be saving it as an STL file. But like I say, I've already done that. I won't do it again. So then the next step you're going to do, if you want to actually make the part, is you're going to go into your slicer. I use the Prusa slicer. Basically, it's the best free one out there. It'll work with any machine. You bring it in, hit that little box, and in this particular case we made leg linkage rear, and it'll lay it out on the build platform, as you can see, like that. And at this point you could take this part, like I said earlier. I did a right click, come down to mirror, and you can say along x-axis, and it actually has now mirrored the part. So then you can go up to File, Export, Export Plate as STL, and you could save the mirrored one as the other side. For example, if the one that was there before was for the right rear leg linkage, then this would now be for the left rear leg linkage, and you could save the file again, and you would then have both your left and your right without having to CAD it up twice. Being this is a structural part, you may decide that you don't want it so hollow in your slicing programs. For example, this is just 15% infill. I'm using a generic PLA at a 0.2 quality setting. Nothing special. It's a mechanical part, doesn't need to be special. But if you wanted to make it more rigid, you could increase that 15% to, well, you can go clear up to 100%, make it solid plastic if you want. Or you could just go 50%, which is probably what I would do for this particular part. And of course, once you've made that selection, you can then just hit the Slice Now button, and it'll slice it. And then, well, I'll go ahead and show you. You hit the Slice button, it has sliced it. It says Slicing Complete. Then you can hit your Export, and it'll export that file you brought in and save it to whatever folder you want. In this case, I have it going to my Mr. Astronaut folder. And just remember that if you did use the mirror thing to flip it, it's going to bring it up with the original file name, so you would need to go in and retype it as, in this case, if the original one was the right, this is now the left, so left rear, and save it that way. And of course, once you have that G-code file that this is made, that's the file you take to your printer to actually print the part. So let's close this out. Let's pull his camera back a bit and let's re-aim things here, like so. You do that same steps for any of the parts you're going to make. So here is the actual part that came off the 3D printer. Actually, I've made two of them. Got another one over here. And if you're going to start to assemble things, the leg on this Mr. Astronaut is actually symmetrical. The same size openings are on both ends. The knee chromed part, which by the way I went back and repainted all the chrome parts chrome again since they were pretty messed up, it's symmetrical. So in other words, there isn't a top or a bottom to the leg, but there is a front. So you kind of keep that in mind, and that the leg part, we're making a left leg, and that means you'd fish this part down through the big opening and turn it so that the nubbin would be facing out, because we're making a left leg like that. And if you did all those same steps for the front one, I'm going to get those parts. Didn't think to have them sitting out. So laid out that one that we talked about earlier in the video. It printed flat, just like this. And those other parts, like I say, the two short ones can get glued on, but not until you've put it into the leg. This one up here can get glued on. And one of the easiest ways to do that is to take an axle, either an axle that's for the body or one of the axle that goes down in the feet. I'm cleaning the hole out in here. There's a little bit of boogering in there. Now if you were going to use super glue, you definitely want to lube up this axle so there's no chance that the glue is going to stick to the axle. But if you're using weld-on number 16, it's only going to melt and join the PLA parts. It's not going to stick to the axle, so you don't really have to worry about it. What does stick to the axle you can normally rub off, so you can just glop a little bit of this on the end of the longer part that printed, and we're just going to shove that on there, and it sets up pretty quick. You can just hold that there. I'll just go leave that axle in there for now, and we'll pop it out after I know that those two have really fused together. Now there's the place for the pin for the arm. I put in a 2mm hole, and the reason I did that was so that I could use as my little axle for moving the arm. It's a tar paper roofing nail. The reason I picked that is because it has a very flat head. It'll sit very flat, and I'm going to take that and just push it into the hole, and it fits really nice and snug. A person could go and put super glue on that if they wanted to make sure it never moves, but I'm just going to pinch it down because it fits really tight. But the one thing you do have to do is adjust. Oh, have I got it? Yeah, I do. So this nail is taking the place of this part, which on the original one is what moved the arm. So you don't want the nail to be any longer than that, because that means it's going to rub on something. So in my case, I'm going to get out my heavy duty snips, and it's going to make it about the same length. Thereabouts. If I don't get it exactly right, I don't think it matters, as long as it isn't too long. It's pretty close. May take just a smidgen more off there, just to make sure it's not going to be rubbing on anything. There we go. So basically this is what we've got now. I shouldn't need that axle in there anymore. So this being a left leg, that pin would be facing outwards, so that means when I assemble this, this is going to drop down like so, and it comes out the bottom like that. So now these short ones, like I said before, these could be just left floater. They're spacers, or if you feel like gluing them in, which is what I'm going to do that. So I'll grab this same little axle piece that I had, and let's put some glue on. You know what? Let's just put the glue right on both sides of this part. Put some there. Put some there. Let's take that and that. So basically I'm just going to hold those till they kind of seal up a little bit. Then I can pull the pin out and it'll be built in there. If I screw it up, I could always come back and probably saw or knock those off and flip things around. In other words, if I put something together here wrong so it wasn't actually set up to be the left leg, made two rights or something like that, you can fix it. Worst come to worst, you just print the part again if you had to bust it up. Okay, so now we don't need these parts, the old broken parts. We're done with them. So it comes to actually assembling this back into the foot We had the lower foot part. We know this ratchet is going to be in the rear. We've got the upper foot part, which I had to have cut off with the knife earlier. Let's make sure that we get it oriented in the direction that it will fit. Okay, that's definitely the way it goes. Trying to remember the stuff. I think I can pull this pin out of this part that we just glued. Kind of cleaning off any of the glue residue. Like I say, it's not going to stick to the metal because it's an actual solvent. It actually melts the PLA and joins them together. It's not a surface glue, it's actually a welding process in plastic. So you can see we have places here and here where these axle pins that I've just been using are going to slide through, and they're going to pin these parts in place. So you could start by putting your foot cover back on, otherwise you're not going to be able to put it on later. You got to put it on now. And we've got the rear, and we know there's pretty much zero chance that I can keep this to where you can actually see what I'm doing until after I've done it. So basically I drove that pin through the rear one. We know that's the rear ratchet. That's where it's going to go. Just kind of center that up. Now we're going to do the same thing to the front one, which is again not going to be possible for me to hold all this to where the camera can see what I'm doing. Really need a separate camera person to do that. Okay, I've got it started. So you can kind of see I've got the pin started. I hasn't pushed it all the way through yet. Gotta get it just, there we go. So now we can see it's pinned there. So in the end, once I'm sure everything's okay, I'll end up gluing this foot cover back onto the pink foot base. But not until I'm sure that I've done everything 100% right, because I don't want to have to try to break that loose again to pull those axles to flip things around or make changes. So that can wait till later. That won't affect anything. Alright, so the next step, I had already assembled, if I can get back far enough. I think I need to move everything back a little bit more now. Even more. And there we go. I've already assembled one leg unit, the right. So this should be the left. Like I say, I've got the tabs that are holding this gearbox are still straight so that I can lift this whole mechanism out. This little washer is very important. If you've lost that washer, you're going to need to come up with something new. There's a crimp on the shaft that the washer pushes up against. It's very important that you still have that in place. Okay, let's see. Separating the gearbox from the back part like that. I'm going to take the leg, and if I've assembled it right, hopefully, you got to line up three things all at the same time. Trying to pinch a wire here. I'm trying to avoid pinching a wire. There we go. Alright. Everything seems to be there. Seems to stand quite securely. That's good. Since I have those tabs bent up in the back, I can't power it up by putting D cells in there. So at the moment, I think I'll just touch some power onto the motor itself here, and we'll see if things are moving. Yes. You see the legs are locking. The clicker is extremely loud, so I think that's going to be good to go. What I'm going to do is glue this styrene plastic parts. Takes a different glue, regular model glue like you'd put a styrene plastic model together with. I'll glue that bottom part on, then we'll come back for a part 3 where we talk about what do we got left. We got some repair work to do on the broken parts that are going to hold the body together, and oh yeah, and I'll go ahead and CAD up a battery box cover on the back, because I don't need it for this one, but if you're trying to fix one of these robots, that's almost always missing when you find one, because the kids would have already broken that or lost it, because it's a separate part, separate from the robot. It's pretty easy to get separated from the toy in 60 years. So I'll CAD one of those up, and we'll talk about that in part 3, and with any luck we'll have we'll put the whole thing together and see it actually work.